Morning students. So today we will understand the concept of distance and displacement in today's class. What is a distance and what is displacement, and we will solve few questions of distance and displacement in today's class. Okay. So what's distance and what's the displacement? What is the difference between the two? What is displacement? Right? So the distance between 2 points, right? The distance between 2 points, let's say A and B. Let's say A and B are 2 points. Okay. Let's say A is a point and B is a point. So the distance between these 2 points is said to be the how far B is from A or how far A is from B, right? So this is called distance. And what is displacement? Displacement is the shortest distance between A and B, right? So here in this case, A to B, let's say x meter or 10 meter, whatever it be, then the displacement will also be the same, right? But what is the difference or what is the definition of displacement? We will see into that. We will see into this. Displacement between 2 points A and B, displacement between 2 point A and B is said to be the shortest distance between these 2 points, right? So we will take one example. Here distance and displacement will be same. Here in this example, right? But suppose there is a, we will just plot the number line, okay, and here this is origin and this is plus x and this is plus y, and if a person is standing over here at position A, at origin is position A, and he goes, let's say 5 kilometer in the east, right? In the number line, what is the usage of this? That in the number line we have taken plus x as east direction, then opposite will be west, and from the origin the north will be on the top. So this will be north and this will be south, downward, opposite to north. So in this question, if a person is starting from a position, let's say at origin, and goes 5 kilometer in east, right? And when he reaches, let's say at point B, right? And he goes 6 kilometer in north, then he will take left turn from here and reach to this point, let's say C, and he goes 6 kilometer in north, right? And after that, if he is turning towards east and going another 10 kilometer, let's say here, he will reach at point D after going 10 kilometer towards east, right? Then we need to understand where is the person standing over now. He is standing at D, and if in the question, if it's given after reaching D he turned towards south and goes another 6 kilometer, so let's say here, so he reaches a position at E, right? Now we need to find the distance and displacement in this question, right? What is the distance and what is the displacement? I expect some answers from your side. The question is that the person is starting from A and reaching E after walking 5 kilometer or 5 units in east, then 6 kilometer in north, then 10 kilometer in east, then again turning to south and going 6 kilometer. So the distance, as I said, distance, what is the definition of distance? Distance is the difference between 2 points, right? So here from A to B, that person covers how many kilometer? 5. So just add on 5. After that, he reaches B. From B, he turns towards north and goes 6 kilometer. So that 6 kilometer will also be added with this 5. So just add 6, right? Now the what is the position of person? That man is standing at C now. From C, he turns towards east, right? So another 10 kilometer is covered when the person reaches D. Now add this 10 in the total distance, right? Now the person is standing at D. After reaching D, he turns towards south and travel another 6 kilometer and reaches the position of E. Now just add that 6 kilometer into the total distance. Now add up these values: 5 plus 6, 11 plus 10, 20, 11 plus 10, 21 plus 6, 27. So 27 is the total distance covered by man, 27 kilometer, if you have taken these units in kilometer, right? Now what is the displacement? It's very good question. It's a concept building question. You will understand that what is displacement. As we have discussed, displacement between 2 points is the very shortest distance, right? Nothing lesser than this can be possible. So if you are starting at A and reaching E directly, just see the origin and your final destination. Okay, so what is the shortest distance? The shortest distance, if you are starting from A and reaching E, then A to B, then why you will go B to C? Because if at B you are having a position, you are seeing two paths, right? One path from B you are saying towards east directly here, and from B one path is here towards north. So in displacement, as I said, this is the shortest distance between 2 points, right? So from B to E, you need not to go via C and D. You should not go like this: B to C, C to D, on reaching D and then coming to E. This is not valid for displacement, right? So when the person reaches B, he directly goes from B to E like this, because we know that displacement is the shortest distance. So we can say, starting from this position, the person reaches A to B and E directly. So displacement is A to B, the vector, plus B to E, right? AB plus BE. What is the value of AB? It's 5. And what is the value of BE? It's, you can see, BCDE is a rectangle. So BE is equal to CD. So just add 10 into this. So 15 kilometer is the displacement. This is the displacement. This is our answer, right? So I think you understand what is the basic difference between distance and displacement, and also the distance is a scalar quantity and displacement is vector, because displacement is having some directions, right? Magnitude and direction both, but in a scalar it's only magnitude. So distance is a scalar quantity and displacement is a vector quantity, right? Now let us see some questions which will clear our doubt or concept of displacement and distance. So there are around 50 videos which I have placed into my channel on distance and displacement. So just going to explain those few of the sorts where it's given that a man starting from or just taking a round or taking a jogging, going on a jogging track which is built on the perimeter of an square park. Okay, this is a square park. So is that person is moving on the square park, and in the question is given that the man jogging around the square park of side 20 meter. So this is the side of a square park 20 meter, and he takes 1 minute in completing this 20 meter. So I will write the question like this: 20 meter in 1 minute. Not 20 meter. 20 meter is the side of the square. He's taking one round. So let's say A, B, C, and D. So he's taking 1 minute to cover A, B, C, D. Right? Now in the question, what we need to find? We need to find, I'm just taking the question now, that in some time is given to you into this question, that in 3 minutes 30 seconds what is the distance traveled and magnitude and direction of displacement, right? So what is the time given? 3 minutes and 30 seconds. So in 3 minutes and 30 seconds, distance you need to calculate, displacement you need to calculate. Because displacement is having magnitude and direction, you need to find that magnitude and even direction of that displacement. So if the man is completing one round of this park in 20 minutes, sorry, in 1 minute, 20 meter is the, I'm just writing empty over here just to avoid confusion between meter and minutes, right? So in 20 meter side, this is the side of the park. So what is the total perimeter of this park? A to B will be 20 added with B to C, then C to D. This will be 20 and then D to A, this will be 20. So the total perimeter is the total distance covered, isn't it? Total perimeter is the total distance covered. What is the value of that? That will be A to B, then B to C, then C to D, then D to A, right? So 20, 20, 20, 20. So this will be adding up 20 plus 20 plus 20 plus 20. So you can see 80-meter distance is covered in taking when the man is jogging around the square park. When he completes one round, he covers 80 meter, you can see here. Now we need to find in 3 minutes and 30 seconds. In 3 minutes and 30 seconds, how much distance he covered. So students, it's given into the question, that in 1 minute he is covering one round. 1 minute per round. Round means the perimeter, right? So 1 minute the man is taking in completing one round of this park, starting from A, going to B, then to C, from C going to D, and then again he jogging and reaching its initial position A. So here we need to understand what is the initial position. Initial position is A, and after that he is just taking the jogging around the he's jogging around the square park, around the perimeter. So in 3 minutes and 30 seconds, what is the total time? 30 second can be said as 1 minute. 1 minute divided by 2. So if you are converting 3 minutes 30 seconds, can't we say that this will be 3 plus half minute, or 3.5 minutes, isn't it? Yes. So 3.5 minute is the time which is given into the question, where we need to find the total distance and displacement covered by man when jogging around the square park in 3 and a half minutes, right? So if he is completing one round in 1 minute, right? So in 3 minutes he will be covering how much? He will be covering in 3 minutes, he will be covering 80 80 along the one round of the park, that is perimeter. So in 3 minutes it will be 3 into 80 meter, because 80 meter is the perimeter of the jogging track of or of a square park. And we have another half minute. So in half minute, that is 0.5 minutes, what he will cover? He will cover 0.5 into 80. So just add up these values. 3 into 80 will be 240, and 80 into zero point 0.5 will be 40. So when we add up, this will be coming as 280. So 280 meter is the distance covered by the man jogging around the park. This is the distance. Now you need to understand what is the displacement and direction of that person when completing this, when he completes this jogging in 3.5 minutes. That first we need to understand and appreciate that person, because he is jogging around the park, because he is very health conscious, and he is understanding that he need to jog, he need to do jogging, right? You should also go for the exercises, right? Yeah, just slightly deviated from the topic. So what is the displacement covered by the man in 3 minutes and 30 seconds? So you can see in 1 minute he is covering A to B, B to C, C to D, D to A. So he is reaching again to A. So in one round the displacement is again 0, because the starting position and final position is same. So in 3 minutes and 30 seconds he is taking one round in 1 minute, then another round, then another round. Let's say I'm marking with a different color here, then another round. So you can see in 3 rounds he will be again at its same position, and in another half minute, last half minute, he will be reaching at, he will be covering the half perimeter of this jogging park, that is the square track, having the square track. So he will be at position C, he will be at position C, right? Now what is the displacement we need to calculate, right? Just the actually this page is filled up, let me change the page. Okay, 1 minute, just a minute. So here we have seen that the person started from A and reaching B, then C, then D, right? So this is the square part. So from the above question, we have calculated the distance. So the distance I am writing over here, distance, just writing the answer, is 280 meter, right? Displacement. So the position of the person, we can say after 3.5 minutes. Position of person at C, because he started from here, reaching B, reaching C, reaching D, reaching A. So in 3 rounds, he will be reaching again at the same origin position. And in the last half minute, he will be at position C, right? So what we will do, we will find we know that the displacement is the shortest distance between 2 points. So what will be the displacement? Displacement will be A to C, this one, A to C. Since this is a square of side 20 meter, so this is 20, this is 20, this is a right angle triangle, isn't it? If this is a right angle triangle and this is a square with side 20 and 20, what is the length of this AC hypotenuse? This is, you know that this is 20 root 2. I think you are able to understand how it's coming. Just apply Pythagoras. So applying the Pythagoras, we get AB square plus BC square equal to AC square. So AC square can be calculated as 20 square plus 20 square root over. This will be AC, and we are getting 20 root 2 as the value of AC. So here we have directly written that. Now, sorry, what is the position of person C at final when he completes 3.5 in when he completes jogging of 3.5 minutes, he will be at C. So this is the displacement A to C, AC. What is the distance of AC? We will see is 20 root 2 meter. So this is the displacement and this is our answer. But we also need to find the direction of that final position with respect to his initial position. This is the position of man. I've just taken the same question and written it over here. Just writing on the explanation of displacement on a new page. Okay. So when he reaches its at position C, this will be the, let's say this is the angle theta, the orientation. So we know that tan theta, tangent of this particular angle theta will be BC by AB, will be BC by AB. And what is the value of BC? BC is 20 meter being a circular path, and AB is also 20 meter being a a square path. I am writing circular because recently I have put a source of distance and displacement based upon the watch question. So I am remembering that one. Okay. So this is a square path, you can see. So tan theta will be 20 meter, that is the this distance, this divided by AB, this distance. So it will be cancelled out. So we are getting tan theta as 1. So if tan theta is 1, we can say that when tan theta is 1, this is at tan 45 degree, right? Tan theta is at tan 45 degree, tan theta is 1. So we can say theta as 45 degree, right? So in this question, we have seen the distance, just I am writing the answers over here. The distance he covered is 280 meter, right? Because in 3.5 minutes he covered the distance like this, 3 complete round, so 3 into 80 meter. 80 meter is the circumference or the perimeter of this square park. So 3 into 80 will be 240 plus 40 meter which he covered in last half minutes. So 280 meter is our answer for the distance. And what is the displacement? Displacement we have seen the final position is C. So we calculated AC by applying Pythagoras to get the value of AC as 20 root 2. So the displacement will be 20 root 2 meter, right? And what is the direction as asked into the question? This is at 45 degree, because tan theta is BC by AB, and BC and AB both are 20 20, so theta is coming as 45. So displacement, as I said, it's a vector quantity and it is always having a magnitude and direction. So magnitude is 20 root 2 meter and direction is 45 degree from his initial position. So this is 45 degree, right? So we have solved this question. Now I have just put around 50 questions on distance and displacement on my channel. Okay, you can refer all those questions to having a better concept of this. And I will take another question of distance and displacement over here. Okay, so let me go to some new page, take some new page. Just a minute. Now I will take one question of watch. Okay, what is the distance which is covered? Just a second. Yes, yeah. So I will take one question of watch, right? Let me bring it out, because what is the concept of watch? You can see a watch, when it starts from its position, it's again reaching to its initial position after traveling or taking some rounds, right? So this is the concept which you need to understand, right? So in a watch, the area swept by minute hand, in an watch, an area swept by minute hand, we need to calculate if the length of the minute hand is 5. So let us see, this is a watch. You know, in watch is 12, 6, 3, 9, right? And the minute hand, what is the minute hand? It's given that into the question, the minute hand is 5 centimeter long. The minute hand is 5 centimeter long. Area swept by the minute hand from 6.5 to 6.40. We need to find. So where is 6.5? This is 12. This is 6. This is 3. This is 9. We know this is 1 or 2. I am not marking the figure as per scale, but this is just for understanding, right? So when the 6.5 will be there, at 6.5 the hour hand will be at this position. Sorry, minute hand will be at this position, and hour hand, which is shorter, can be here like this. So this is the position of 6.5. So from 6.5 to 6.40, from 6.5 to 6.40, what is the distance covered and displacement covered by this minute hand, whose length is 5 centimeter, right? So when 6.40 will be there, then where will be the minute hand? It will be coming at this position, because when the minute hand is at 8, it is 40, right? So this is the position of 6.40, right? Now what is the distance covered? If the minute hand is of 5 centimeter length, so I am writing it over here as 5 centimeter. So just see this clock as a square. See this as a square. If this is a square, this will be the radius. This 5 centimeter, that is the length of this minute hand, will be acting as a radius, right? And what is the distance? What is the distance covered? The distance covered is 2 pi r in one round, right? 2 pi r. So we can say in a watch the concept is very simple. Total number of angle or degree angular displacement or angular distance covered by the watch is 360 degree, and we can say that in 360 degree what is the area covered, or the perimeter covered, that is 2 pi r, right? 2 pi r. Now we need to find from 65 to 640 how much is the distance and displacement and direction, right? So here you can see from 65 to 640 the position will be like this, and this will be theta, right? We need to find, in this question we need to find the distance and displacement of the minute hand and area swept from 65 to 640. So in this question is a combination of physics and even the question of mathematics mensuration, right? So as I said, 360 degree is covered into one round. So if 360 degree is covered into one round, then we can say that out of there are total how many minutes in one round? There are total 60 minutes and 60 minutes in one round, that is we can say 360 degree, or 360 degree when the minute hand completes 360 degree, it covers 60 minutes or it measures 60 minutes. So just apply the unitary method. So 1 into 360 will be 60 minutes. So in 1 degree it covers, just take the reverse of this, in 1 minute it covers 360 by 60, so this will be 6. So when the minute hand covers 6 degree, let's say here to here, if this angular displacement is 6 degree, then we can say 1 minute of time is covered, or 1 minute is read on the watch, 1 minute, right? So in 6 degree of angular displacement, 1 minute is counted on the clock, right? And we have hour hand. So don't forget that we are considering and solving this question for the hour hand, sorry, minute hand. Just mentioned over here, minute hand. So when the minute hand covers a angular displacement of 6 degree, we can say it covers 1 minute, right? Now we covered from 6 to 640. So from 6 to 640, let us mention the time. From 6 to 640, how much is the time which is captured or covered? Total time will be 640 minus 6, that will be 40 minutes. No, the initial position was at 65 here. So from here to here, from 65 to 640, he is covering 35 minutes, isn't it? 35 minutes. So 35 minutes is covered from 65 to 640 when the hour hand is moved from here to here. Now the total angular displacement will be how much? We know that in 1 minute 6 degree is covered. 6 degree of angular displacement is covered, right? So in 35 minutes, how much angular distance will be covered? It will be 35 into this 6 degree. So this will be coming at 6535 3 215 degree. So 215 degree is covered over here. 215 degree, right? Because you know that when the hour hand completes one round, it will be 360 degree which is covered, right? Now when he start from 6:05, the time was 6:05, and when he reaches at 640, the total angular displace or the angular distance is covered is 215 degree, right? We need to find the area swept by this minute hand and the distance and even the displacement, right? So here just simply you know that area of a sector, first calculate the area swept by the minute hand. So area of the sector, you know that theta by 360 into pi r square. This is the area of sector. So what is the sector? This is the sector, this one, right? So theta, what is the value of theta? We have calculated 215. Just put up this value, 215 degree divided by 360 into pi. You know the value of pi is 22 by 7 into r square. R is the radius, which is the length of this minute hand. So what is that? It's given 5 centimeter. So this will be 5 square. So just calculate this. So we get the area covered by this minute hand. Okay. I'm not going into the calculation, right? And what is the displacement? Just we know that the displacement is the final and shortest distance from the initial position. Here this is the initial position and this is the final position, right? So if you have to mark this, you can say this is the displacement. Just I'm taking different color pen. So this will be the displacement, right? And what is the distance covered? Distance covered is from here to here, that is right. So this is the distance which he covered starting from, let's say, position A, and when he reaches it at position B, that is when the time is 640, right? I hope you get the concept of distance and displacement. Yes. So here the area covered by the minute hand from 6:05 to 6:40 is calculated here by using the concept of area of sector, that is theta by 360 into pi r square. And we know that in 1 minute the angular displacement, the angular distance which is covered is of 6 degree. So from here to here is 35 degree, right? Is 35 minutes, is 35 minutes. So in 35 minutes he will be covering 35 into 6, that is 215 degree. So the distance of that particular person when he reaches at B will be here, right? And this is the distance. So what you will do, you know that if this is 6, what is the perimeter? Perimeter will be perimeter or circumference is equal to 2 pi r, right? So 2 pi r is the circumference. If 2 pi r is the circumference, we can say that if 2 pi r is the circumference, when the minute hand started from A and reaches B, what is the distance covered, right? So this part, the dotted line, you can see this is the distance which is covered, right? We know that if the perimeter is 2 pi r, that is 2 into pi into 5, let's say 10 pi. 10 pi 10 pi is the perimeter. Then in this will be completed, this will be captured into 60 equal installments, right? 60 equal installments, because there are 60 minutes in a, in one, when the clock covers, when the minute hand covers one round, it covers 60 minutes. So here you can see it covers how many minutes? 35 minutes, right? So I have to take another paper, or let me explain it over here, otherwise it will be little more complex to understand on different papers. So here I, I am saying that 2 pi r, 10 pi is the perimeter or circumference of the watch when the minute hand is moved around one complete, when it completes one complete round. When the minute hand completes one round, it covers 2 pi r, that is 10 pi, that is the distance. Now when it covers 35 minutes, when he covers 35 minutes, so in 1 minute how much is the distance he covered? Let us find it out, right? So in 1 minute he will be covering 6 degree, right? So if this 2 pi r is the total circumference, then just divide it by, just divide it by 60 equal parts. So the circumference is 2 pi r, which we have calculated as 10 pi. So 10 pi is the total circumference divided by 60. Just cancel out. So pi by 6 is the distance. Let's say pi by 6 meter is the distance covered in 1 minute. In 1 minute he is covering pi by 6 minutes, pi by 6 meter, right? No, it's centimeter. So just this will be centimeter, right? Pi by 6 centimeter. So in 35 minutes, in 35 minutes, that is the total time, he will be covering 35 into pi by 6. So this is the distance he covered when the watch started from 6:05 and reaches 6:40. So this is the total distance. What is the displacement? That is the position of the man finally starting from the initial. So this will be the displacement, this one, right? How you calculate it? We can calculate it. It's a, just simply just use some concept of circle over here. Okay, here this is given the 6:05, at 6:05 you are here and 6:40 you are here. So this will be just acting as a chord. This is the displacement. When you calculate the length of this chord, we can say that you know the displacement value. You know, this is a center and the minute hand is having a length of 5 centimeter. So this will be 5, this will be 5. Draw a perpendicular from here. Okay, and you can use the concept of circle to calculate it. Otherwise, when you need to show it, you can show that this is the displacement A to B. Now how we will find it? We have calculated the distance, that is 35 pi by 6, but what is the displacement? This we need to find, right? So displacement is this length of this chord AB, right? How we will be calculating this length of chord AB? You know that this is 6, this is 5 and this is 5. and we need to find this distance A to B. So this will be the displacement which we will be capturing at the final position. So the basic thing which we have just asked into the question, what is the area swept by the minute hand from 65 to 640, which we have calculated, right? This will be this value. Distance 35 pi by 6. When you need to calculate the value of this displacement, then the length of this chord need to be calculated, and this chord value will only be there when you know that a perpendicular drawn from here center, let's say center to the chord, it will be 90 degree, and the hypotenuse length is 5. So we need one more value into this question. So this should be given to you, this perpendicular. If this perpendicular is known to you, if this value is known, let's say x, okay, then we can calculate this value, let's say A to P. This will be calculated by this simply 5 square minus x square, take the root of that, apply the Pythagoras to get the value of AP, and just double it, because you know the perpendicular drawn from center to the chord is bisecting it equally, right? So AP will be doubled, so we get that value, that is our displacement, right? Displacement. We have considered questions and based upon the understanding, okay, and where I have put dots, but here this value will be required to calculate this displacement AP. Which value? O2P, that is our perpendicular. So in this way we will be solving the numericals of distance and displacement, and we have seen how we have captured different questions of squares and man, jogging, tracking, and the basic concepts of distance and displacement. Okay, hope you enjoyed the learning today, and just keep on learning, and for any doubts and queries you can put up into the comment box. I will confirm. I will just marking it again into my channel, and hope you liked it. Thank you so much for watching. Keep on learning. All the best. Bye bye.